So, hello everyone, welcome to our channel. So, in this video, we are basically going to discuss about the one problem, which is a wide explosion. It is the GFG problem of the day of 5 March. So, let's first read the problem. Uh, I suppose you read, but let me read it. So, Geek is a chemical scientist who is performing an experiment to find an antidote to the poison. The experiment involves mixing some solution in a flask based on the theoretical research he has done. He came up with an n cross 2 array mix where mix size equal to xy. It means that solution x and y needs to be mixed for making the antidote. And there is another array which is a m cross 2. In this array, the the array name is the danger. And what is the meaning of the danger I? If the danger I is equal to pq, it means that the solution p and q is going to be mixed. So what we have to find actually, so Geek is going to do the experiment sequentially, and we have to find that suppose if we mix the two danger solution, then it is going to be explode. So we have to uh, don't do that. We are basically going to mix the all the solution and see that by mixing these two solution, it is going to burst or not. If it is not going to burst, then we have to return the yes for that. And if it is going to be burst, then we have to return the no for that. So let me take the first test case and I explain you. Okay. So here, okay. So actually, this is basically the problem. Okay. If you know the data DSU, data disjoint state union, then this is a very easy problem. But if you don't know it, then I think it's a tough problem. So I recommend you to go and watch some video on YouTube of visual settlement, and I also put some link in the description box so that you can learn from them. And they are very good videos. Okay, and that DSU is a very important topic of the graph, so it's my recommendation, and it is a must that you study that you see that video and then come here. Okay. So, okay, so I suppose that you have knowledge about the DSU. So let's just start the problem. Let's just start the first test case. So, okay, okay. Suppose what I'm going to do, that suppose this is the first, this is the, I take this part, 1 and 2. Then I'm going to make them into one component like this, 1 and 2 in the one component. Okay. After that, I'm going to. So I see that is by attaching 1 and 2 in the one solution, is it going to burst? So I see that in the danger. For every node, for every value of the mix, every ith value of the mix, I'm going to see in the danger, is it going to explode or not? So I'm going to check that is 1 and 3 are in this component? No. Is 4 and 2 in this component? Basically, in this problem, the one component is representing the one full solution. And if there is any one node which is in the danger category, and then this whole solution is going to burst. So we have to see that in every component this should be not in there. Like 1 and 3 should be not in the one component, and 4 and 2 should be not in the one component. If this is not, then it is, and if this is, then it is a no, giving me no. Otherwise, yes. So I'm attaching 1 with 2. Okay. After that, I'm going to so I see that it is a good 1 and 2 does not, because 1 and 3, 1 and 2 is not here, 1 and 2 is not also here. So I'm going to return the first case as. Let's see the second. When the I value is equal to 1, 2 and 3. So in this case, uh, when I'm going to attach, when I'm going to mix the 3 solution and the 2 solution. So 2 is here, and when I'm going to mix the 3 solution here, like that, then what happens? We can see that the 1 and 3 are come into this one solution. So 1 and 3 are in the danger, so this is going to be explored. So I'm going to return the no. And is it valid to add the 3? No. So if you see closely, okay, just a minute. Okay. So in the problem, it's saying that it is said that if the solution is going to explode, then we are not adding this thing. So let's erase this. Okay, nice. And still the 3 is in the different solution. Okay. So after when I go into 4 and 5, then I attach 4 here and 5 here. Okay. So after attaching this, so there are actually two solutions currently. The first one has 1 and 2, and the second one has the 4 and 5. So I'm going to see that is by adding this 4 and 5 the danger occur or not. So we can see that this is the 1 3 solution and this is the 4 2 solution. So there is no any danger. After that, I'm returning the yes, and after that I'm going to on the 3 5 part. So basically, when I'm going to mix the 3 with the 5, then what happened? 3 come here, and let's check that after adding this, is there any different thing occurs or not? So we can see that okay, actually 3 is not attached here because we know that when we attach things in the DSO, then it is basically going to attach on the node which has the highest rank. So if we see that the 4 5 has a 2 rank, so it's going to attach here. That's why I told you that first study DSO, then come to this video. So when I attach the 3, then I'm going to see that is there any danger occur? So we can see that the 1 3 and 4 2 is never occur here. This is 1 2 solution. This is the 4 5 3 solution. This is the whole component of 4 5 3. So there is no any chance of the explosion here. So after that, then I'm going to, so I'm written this. But when I'm going to attach, see the 2 and 4. So what happened? This is the 2, this is the 2 part, and this is the 4 part. So when I'm going to attach, then it is attached like this. Uh, if you know the DSO, then you know why. Because we are actually attaching the parents of the both things. And it has a high rank, so it is going to attach here. So after that, we can see that after the fifth process, we can see that there are a lot of the danger occur. For example, the 1 and 3 are at 1 and 3 the first danger, and 4 and 2 is also come in this solution. So this is the danger. So that's why we are returning the actually the no. Okay. Okay. Amazing. Okay. Let me tell you the other example. So what's happening there? Again, let okay. Uh, I don't know how can I erase all the things once. Let me erase it. Okay. Nice. So what happened in this case? First, we are going to see the 1 and 2. Okay. This is 1, and I'm attaching the 2 with it. So is this cause problem? Yeah, it's cause problem because the 1 and 2 are here in the danger situation. So we cannot do that. So I'm simply returning the no, and I'm going to erase it. That this is not happen. This cannot be happen. Okay. After that, this is the 2 comma 3 and this is the 1 comma 3. So I'm going to attach the 2 comma 3, and let's see that it cause explosion or not. So this is 2 comma 3. So we can observe that there is no any 2 comma 3 solution. The 1 and 2 have cause explosion and the 1 and 3 cause explosion. But if we attach 2 and 3, then it's perfectly fine. So I'm going to simply return the yes part. After that, what happened? I'm going to attach the 1 with 3. So when we are attaching the 1 with 3, so this happens. So actually 1 and 3 are coming to one solution and that explosion happens simple. So this is going to return with a no part. Okay, amazing. Oh shit. Let's go. Okay, so okay, I think so. What is our actually approach? What is the approach we are going to follow? So for approach, I'm from here. Okay, so what we have to do? Suppose this is the our component which is formed till ith part, and this is the another component which is formed. Okay, and I want to attach the 3 and 8. I want to mix the 3 and 8 part. Okay, so here. So what I'm basically going to do that I'm going to find the parents of the each. What we want to attach. Suppose I want to attach the 3 in it. So I first find the what is the parent of 3. Parent of 3 is equal to means that parent of 3 is 1. It is basically the parent of the whole component. And the parent of 8 is equal to 6 in the another component. Okay. After that, I'm going to traverse the whole danger array and see that if the attaching this both the thing causes problem or not. So for this, I am again going to find a parent of what parent of like 5, which is 1 here. 5 parent is 1 and parent of 7, which is parent of 7, which is 6. So here we can observe that the parent of the thing which is in the mix is equal to the parent of the thing which is in the danger part. So if this case happen, it means the explosion happen. Okay. Why? Because suppose we attach it, we does not care about that, we attach it. Then what happened? This 6 is going to make the connection with this one. So what happened? You can observe that after that. The thing which is 5 and 7. So 5 is here and the 7 is here. So this become the whole one component and this causes the explosion, which is not good. So I'm not going to attach this. Okay, nice. So we are actually going to check the, so you can ask me that it's maybe also happened that in the danger area, this is given as the form of the 7 comma 5, not 5 comma 7. So yeah, we are going to basically check for the suppose if it is given as a, okay, let me write it. Uh, if in danger array, it is given in the form of 7 comma 5, then parent of 7, parent of 7 is equal to 6, and the parent of 5 is equal to 1. So the order is actually here reverse. So that's why we are going to basically check if this can be equal like first, second, or first and the second of this and the second of this to be first of this. So we are basically going to check the both the thing. So basically what is our approach? That for every mix of I, I'm going to check in the whole danger array that this causes the problem or not. If this does not causes the problem, I'm going to simply attach in the our DSU. And if it causes the problem, going to simply reject it and return the answer as a simple no. Okay. So let me write the function for the DSU. You can saw that video for more clearance. Since the value of the n can be go up to 1000, so I'm going to take the parent array as 1005 and int rnk 1005. Okay, this is the first function. Like make union means that you can I is less than n. There are basically three functions involved in the making the DSU part. The first is the make union, which is for initializing the everything. So Initially, everyone has its own parents, and rank of everyone is equal to 1 because there is only one element in the component. The first function is the endpoint set. We are basically passing this. If parent of x is equal to x, return x. Otherwise, by using the parent and the rank, actually its time complexity become big of 1, approximately big of 1. That's thought. Return parent of x equal to find set parent of x. Okay, nice. Okay. After that, third function is actually uh, next set and let it write make union. Uh, it takes two parameter and make them union. Set A P2 is equal to find set of B. So if P1 is equal to P2, then just simple return means that they are basically belong to the same component. And if the rank of P1 is greater than rank of P2, then I'm going to do that like P1 has a higher rank, so its parent is and rank of P2 becomes rank of P1 plus rank of P2. Okay. And the last case, when the rank of the P2 is greater than, that means the P2 has more number of elements. So let I'm trying to understand. I'm trying to explain this. That suppose this is the first component, this is the second component. Since it has a higher rank, means the high rank means the how many numbers of the nodes are there. It has a how many? One, two, three, four, five, five, and it has a three. So since it has a high rank, so I'm going to attach this thing with the larger one, so that it's going to help me in the time complexity part. So else parent of P1 is equal to P2 and the rank of the P1 is equal to rank of P1 plus rank of P2. Nice. Okay. So this is the basically whole function of this. And what I'm going to do, and first I'll the mix set function for making the initializing everything. Okay. Now, now I create vector string answer, which is for returning the all the things like yeah, no, yes, no. Now I'm going to traverse the whole array. Okay. Suppose this is the max I 0 and it b is equal to max I comma 1. Okay. Now x. I'm going to find the what is the parent of this. For example, if I want to attach the 3 and the 8, then I first find the what is the parent of the 3, that is 1, and the what is the 6. So I'm basically finding this thing. Okay. So find set of A and int y is equal to find set of B. Okay. Now I'm going to check in the whole danger array that it causes any problem or not. So for checking that, let's take some blue full flag is equal to 0. And if it causes the problem, then I'm going to set the flag is equal to 1 and just break it. So let's find this as a P danger I comma 0 int q is equal to find set danger I comma 1. Okay. Now what is the P and Q actually? Actually P and suppose danger is the 5 and 7, then it is actually the 1 comma 6. I'm going to find the parent of the 5. This is the P and this is coming to Q. So this is the first thing is the danger of first part, parent of the danger of the first part P, and this is the danger of second. So this is in the Q. So what I'm basically going to check that if P is equal to X and Q is equal to Y, or P is equal to Y and Q is equal to X. So why I'm checking the both the conditions of okay. Uh, I have this. This is basically equal to okay. Okay, this it is actually X. This is actually Y, and this is P, and this is Q. So I'm going to basically check this X with the P, and the first is, and this is the Y with Q. But it may happen that the in the danger error this is given in the form of the 7,5. So this thing going to be reversed. That's why I'm also checking the reverse part also. Here P is equal to X, Q is equal to Y means that first with first, second with second, and here P is equal to Y and the Q is equal to X. It means that the first part, sorry, this Q is going to this X is going to be checked with the second part Q. Here X is equal to Q and P is going to check with the Y. So I think you understand that. Okay, this thing happened. It means that it is in the danger. So I'm going to just click the flag is equal to one and the break. So what will happen after that? I'm going to check if it is in the danger. Then what I'm going to return? I'm just attaching the no. Otherwise, if it is self, if it is safe to add the both the solution, then I'm going to uh, make them S and I'm going to attach it. Means that after the support it is safe, then I'm going to just simply attach the 6 with the 1. So how this thing happen? Make union, call the A comma B. And finally, I'm going to return the answer. Let's check that is it any error or not, or is it running? It's give me runtime error. Okay, let me check why. So let us find the what is the so actually there is two mistakes. The first one I here actually by mistake I uses the I, which is actually J. And the second thing is that here actually since the rank of the P1 is greater, that's why the parent of P2 is equal to P1. And the rank of P1 is going to be great because we are attaching the P2 with the P1. Okay. Okay, now it is compiling. Let's submit it. Okay. So so here it passes all the cases. Okay. So basically, so let's revise the whole thing. What we're actually doing. We are for in the here we create the answer. We are going to traverse the whole mix array. We are find the parent of the both the things, and for that parent, we are going to check in the whole danger array. Is it causes any problem or not? If it is not causes any problem, I'm simply going to make the S and unite them both. And if it causes the problem, I'm simply going to do it no. And how I'm going to check that is it causes the problem or not? By this method that I'm going to find the both the parents and simple check it. So I hope you enjoy this video. If you enjoy this, please like and subscribe the channel. Okay. Thank you.